Children, now we are going to learn about observations of Ellingham diagram. Already I taught Ellingham diagram. X-axis temperature is there. Y-axis delta G naught value is plotted. And so there are 4 observations. First we are going to see the observation 1. See, already you know in Ellingham diagram, for most of the metal oxide, the line moves upward for different metal oxide. Only for formation of carbon monoxide, the line goes downward. Apart from that, for all the metal oxide, the line moves upward only. If the line moving upward, it means the slope is positive. The line moving upward means slope is positive. That is Ellingham diagram. Here temperatures, here delta G naught value. Likewise, the lines move upward. So upward means the slope is positive. Reason for this one. See now the metal which is in solid state combining with oxygen in gaseous state forming metal oxide which is also in solid state. So here solid, gas, solid. So for oxygen when the reaction moving on, when reaction going on, gas is used up, oxygen gas is used up. So when oxygen gas is used up, entropy becomes less. Entropy means disorder. For gaseous molecules are loosely packed. For liquid means it is somewhat closer. For solid means it is fully closer. So this is called randomness, that's disorder manner. So while the reaction is taking place, all the oxygen get used up. So when the oxygen gas get used up, for that situation, S2, that is S1, entropy of the initial state becomes more than the entropy of the final state. So what is delta S? Delta S is equal to S2 minus S1. That is delta G naught equal to del H naught minus T del S naught. S naught. So if del S naught is a negative value, negative become positive. So del G naught is equal to del H naught plus T del S naught. So if it is a negative value, that is, see the Ellingham diagram. Here the temperature goes on increasing. So when the temperature goes on increasing, delta G naught becomes positive, goes on decreasing. So delta G naught becomes positive or less negative. So the metal oxide, at this stage, the metal oxide decomposed to give the metal. Metal oxide decomposed to give the metal. In your book it is given, for the metal oxide formation, the slope is positive. That is, oxygen gas is consumed during the formation of the metal oxide, which results in the decrease in randomness. Random means entropy. So delta S becomes negative and makes T delta S positive in straight line equation. Such a way explained. These 4 lines you can learn. For this explanation only I have explained here. Now consider the observation 2. See in the Ellingham diagram, most of the lines moving upward. See this line, this red line, carbon plus oxygen giving carbon monoxide, moving downward. Moving downward means it has a negative slope. First observation means for all the metal oxide moving upward. Moving upward means slope is positive. Now for this one you see this only line moving downward. So it becomes a negative slope. Observation 2, carbon plus oxygen forming carbon monoxide on balancing 2 CO2. This is solid, this is gas, gas. When calculating delta Ng means product moles minus reactant mole, gas, 2 moles of CO, gas, 1 moles of oxygen forming 1 mole of that gas. So 1 mole of oxygen when used up giving 2 moles of CO. For 1 mole of oxygen, 2 moles of CO is produced. So now there is more gas, so free to move. So what happened? Entropy get increased now. So calculating delta S, S2 minus S1, final value minus initial value. So total delta is having a positive value. So delta G naught is equal to delta H naught minus T delta S naught. Delta S naught positive, negative into positive becomes a negative value. So when temperature get increased, delta G naught becomes more negative or the value become less. So CO is stable at higher temperature. This is an important question. Why CO is stable at higher temperature? Second observation given, explanation only I taught now. So this is the answer for the second one. Why CO is more stable at higher temperature? Shortly, if you are saying means the slope becomes negative since the line moving forward. So when the temperature get increased, delta G naught becomes more negative or the value becomes less. So CO is stable at higher temperature.